Alright, so we're going to hit calibrate on screen. Wash bottle. Start off with pH 7. Alright. Wait for the voltage to settle. Okay. Keep. We're going to clean the wash bottle, clean the electrode again. And we're going to put it into pH 4. Okay, hit OK. Now we're ready to take the pH of KBR. Alright. pH is going to be around 6.4.
Alright, so we're going to start off by calibrating. Let's see here, wash this off. Now, our pH 7 solution. And wait for the voltage to stabilize. Cool. Alright. Wash that off. Then we'll start on our pH 4.
Just go ahead and hit it.
Do what? Okay, that's good. Okay, so we're all calibrated.
Alright, that's okay.
Do what?
Okay.
Oh. Alright, so we'll go ahead and test out our potassium bromide and see what we get. Alright, so our pH is going to end up being about 6.4, so go ahead and mark that down right here. 6.4. Good to go.
All good.
Okay, so we're going to calibrate.
Oh, you can see.
Good. Rinse this off. And buffer 7.
Point out. 7. Keep.
Rinse this off. Everything buffer 4.
Oh, yeah, we're gonna keep that. And now it's calibrated. Now we're gonna rinse this off and find the pH of potassium bromate. Ready? Go. Alright. So the pH of potassium bromate is 6.45. Cool.
Acids donate their protons, and strong acids completely donate all of their protons and deionize completely. So, because of that, they don't have any protons in order to go in the reverse direction and have equilibrium. So it's completely negligible because it's so small. So it only moves in the forward direction, which means it completely disassociates. And so the weak acids don't completely deionize and still have some protons left over. And because they have enough to be considered, it also moves in the reverse direction, meaning it goes to equilibrium. Solid Image Fitness, where people go to get buffer, and I'm here to describe how a buffer works. So if you look at a pH versus volume graph of a monoprotic acid, the flat part in the middle is where the buffer is actually working, and once it gets past that, once the buffer capacity is reached, is when it starts shooting back up. So a buffer capacity is the amount of acid or base that can be added to the buffer before it begins to change, like before the pH begins to change massively. The buffer range is the range where a buffer can effectively neutralize the pH of an acid or base added before the pH begins to drastically change of the buffer. A buffer is created by adding a mixture of a weak base or weak acid with its conjugate acid or base. And this makes it to where when a hydrogen ion is added, the base part of the formula or of the mixture will neutralize that. And when a hydroxide ion is added, the acid will neutralize that, which is going to keep the pH relatively the same.